So I gather from your answer that your man page might include, if you want to know if this feature is, the background, what did you call it? Async.
You would say, like, if you're wondering why this is active, runs equal status, it'll tell you how much is remaining to do.
Gotcha.
And I guess another thing would be, it'd be nice if, say, in the future when we have these things like the data set thing we were talking about, if you could like list the data sets that it was on. That's what I was wondering. But that's going to become very feature specific.
But it could at least be best practice to document it. So you could do something like, if you want to figure this out, run zpool list -o name, comma, encryption. And then the ones that say encryption on, those are the ones you need to destroy to make this go back to being just enabled.
Excellent.
All right, so someone start saying something?
I was going to say is that when you ask that question, like underscore encryption, that must know about that property. So that's like, how do you make sure that all works when it comes to, hey, are you activating the pool to have that feature? Because you're asking the question to have the feature.
Well, the software would know about the property as soon as, the software always knows about the property, whether the feature is enabled or not.
So a little bit more back to like things you should and shouldn't do when implementing features. And first, mostly for people on the internet later, but there's a big block comment in cfeature.c about adding features. So obviously you can't read that yet. So
I swear it's there.
But there is a comment in ZFS.
Hey, ring the bell.
There's at least one comment. All right, so a little of the internals of what's happening inside of ZFS. There's a reference count per pool per feature, and basically and for each enabled feature. Sorry, so if the feature is not enabled on the pool at all, there's not even a reference count. Once you enable it, the reference count shows up. It's set to 0. As long as it's 0, that means enabled but not active. Anything other than 0, positive numbers, there's no negative numbers, means active. And it's up to the feature, what they want to do with this. And we envision that as like when you do the data set thing, like you count the number of data sets. That way you don't have to go searching every time you destroy one to see if there's any others left over, to see if you should deactivate the feature. So you try to, hopefully this can catch most cases where you design your feature so that this count naturally goes to 0 when the feature gets deactivated. Let's see, and we care about, and I think this has always been the case for upgrading ZFS, but we want to minimize the time it takes to do the actual upgrade and do the work, at a deferred state when you actually, create the RAID devices or, set the property on the pool, or set the property on the data set that enables crypto, or whatever. So they're split into, you check if it's enabled to figure if you should execute the code path for the feature at all. So if it's not enabled, you shouldn't ever touch any of the code for the feature. And then you check if it's active to see if you should do the setup, kind of thing. And I mean, hopefully, like async destroy is a good example of this. It does something similar.
Could you walk through, I think an interesting historical one that maybe you would be like the user space used, which today you type ZFS, it's a ZFS feature, not a ZFS one, but you type ZFS upgrade, synchronously it goes and calculates all this data, and how would you do active versus inactive, and how would you sort of follow that?
So for that, that's an example of something that's adding new state that needs to be tracked kind of in perpetuity. So that would probably never be, but I think that one of the big feature benefits that would fall out of this feature flags is just the being able to do it read-only. So like with the user space use stuff, you'd be able to enable it, it would immediately become active, but it would be backwards compatible read-only. So it would be a feature for write. In other words, you need to know about this to write to the pool, but you don't need to know about it to read to the pool, read from the pool.
And maybe async destroys might be a good example too. So what it does is basically when you destroy a data set, it says, is this enabled? If no, run the exact same code you would have before. If it is enabled, is it active? If it's active, then you just append to the list or whatever. If it's inactive, then you do all the setup of creating the free list and that stuff. And then when you finish clearing it out, you destroy that, you get all that off the disk again, and then you set it back to inactive. I already changed. So let's see. And I said this before when I was talking about systems, but we want to always kind of make it so that the default is you enable all features. So we want to avoid like incompatible features,
You
or
have to choose between two.
yeah, or like you know, you might want to maintain features that for some reason like you want but nobody else in the world would ever want, and you kind of like, we don't really want people pushing that back, I don't think.
Like user use.
Yeah. Or actually, so I put a note here. So if you have a feature like that, or any other, there's plenty of examples of this other feature like dedupe or crypto, where if you want to have the ability to kind of disable your feature, that shouldn't be done with the feature at properties. Those should kind of always go to enable. If there's a reason that someone want to enable and disable your feature, you have that as its own separate property. So it doesn't kind of mess with how people, so the people don't have to get all stuck in how the feature stuff works. Because obviously, I spend at least like 20 minutes not talking about it. It's not simple. So, yeah. And then the last point is feature flags doesn't magically help us merge code for two conflicting features. And I have a couple examples. We have all the check summing algorithms, that are like have enum values that are written to disk. So if two organizations decide to come up with a new check summing algorithm, their enum values can't conflict, or you have trouble when they try. You won't have trouble when they. No longer will you have trouble when they try to import each other's pools, because it'll just say you can't use these two because one of them has this feature with this algorithm, and the other one has this feature. But then what you really want to move to is eventually you want to merge those two code bases, and then you have a problem. So there were actually some suggestions in the original feature flags proposal for how you kind of like indirect this. So you can kind of say like, on this pool, this number means this algorithm, and it can be different on another pool. That's not implemented yet. Even more exciting problem is what happens when Delphix wants to use bit X to store some flag, and someone else wants to use that bit for something else, in some data structure that exists on disk. I don't know, my best solution is we avoid that situation.
Problem solved.
Matt, George, Shrock, just thinking back to history, how many features fall into these kind of these categories?
Very, very few.
That's what I thought. I mean, I assume that the compression algorithm seems to be the one that seems most likely. I mean, would it be, is it unreasonable where you do have an enum to encourage folks to push up their definition of the enum? It's kind of as quickly as there's a consensus that someone wants to do a new compression algorithm to get the enum pushed up?
Today the solution for this kind of stuff is like discuss it, tell us early and often so that we can all coordinate that. That's one of the reasons that we started the ZFS working group, is so that even people that don't want to communicate publicly about what they're doing can tell other people that they trust, like, hey, by the way, we're implementing this feature, we're going to be using these bits. Maybe they can say, we're using it, we don't care what you do, but we're just letting you know, like, we're going to do it anyways, whatever you do, so you can either get out of our way or not, right? These things are not so friendly to open source. We don't want those kind of activities. We want everyone to be discussing them openly in the public forums, and so we can all coordinate it. But we really want to avoid, the situation where we have different on-disk formats that can never have the possibility of being merged.
And bits in the block pointer, I mean, how frequently have they been consumed for features?
There's not many left.
Right. I mean, I mean, it seems that can be settled with a duel between
which kind of makes the problem worse.
But I mean, how many features just
Ditto blocks.
in history? Okay, all right, okay. So we can reuse that bit.
The last one that was used was crypto.
Right.
Dedupe.
Yeah, the only, I mean,
We have
aside
some
from
stuff
ancient
that
history,
denote like the system at.
I think that's just the dedupe bit and the, like you said, the crypto bit,
Okay.
the block pointer.
Okay.
But then, new compression and checksum algorithms also impact the block pointer.
Yeah.
So that's why, that's actually a solvable problem by introducing another layer of indirection. So we have a plan for that. We have a little bit of code implemented, but it's a lot more tricky than it appeared at first blush. So.
Well, there's
what
some
our
stuff
intern
in,
found out.
I mean, this is
At
all
what
the
cost?
Z-tool
This was
level
great
stuff, but
cost.
there's also data set and ZPL level stuff. which is presumably in the pipeline at some point for versioning for data sets and
Yeah,
ZPL.
right.
We've done stuff with the.
So the ZPL has had many fewer version number changes, but it's also like an area that's ripe for enhancement because it's less impact on the whole rest of the system. I think that we'd like to make it easy for people to make version number changes in the ZPL as well, so we'd like to extend the same idea up to there.
And presumably you'd be able to leverage the same nomenclature and ideas?
Yeah, it would work. In fact, Basil's code sort of did it. It was just like a lot more to test. So
Right, cool.
that's not in there.
So one of the key takeaways I want to make sure gets pushed up or out on here is that if you're in an organization hacking on ZFS and you think you're tweaking bits, right, or adding numbers or whatever, talk to Matt, please. Please talk to Matt. Yeah.
He's the John Pastel for ZFS.
Well, I mean, even if you don't want to say anything publicly, at least talk to Matt. Get yourself a number reserved, right? You can talk to me too.
I left on that.
Or you know Matt, so.
All right, well, thank you to
Thank you.
Chris.
Awesome.
I think there's lots of, maybe a couple questions, but there's lots of time for kind of informal questions. Is there any last questions that?
Is there maybe something that would be useful is a programmatic way to indicate that a feature is reversible, that there is a way to remove, that the feature can clean up after itself and go back to enabled state.
That it has a deactivate.
Yeah, it has a
It
deactivate.
would deactivate.
Features could theoretically include their own, like, whatever command that deactivates them. That's up to the feature. Whether or not it can be deactivated, I think right now the plan is just to do that. That's a documentation.
So I think one thing is man pages, as Matt said. I think the other thing is we're going to learn about features as we create them. I think that we could invent a bunch of mechanism for generic deactivation, but then when we actually have a feature which needs that, it may or may not apply. So we'll kind of fault that in as we find features for which that's applicable. I think the first ones that we've looked at have been pretty easily invertible.
And that applies to, like the checksum indirection and whatnot. Like when people have new checksum functions, new compression algorithms, then let's go off and invent all this stuff that we think can be done. But we didn't want to have the burden of getting everything all done, but not having any consumers of it, because it's just like, that's impossible to test really well.
And the code just ages and then.
The feature stuff implemented because I needed tracing destroy. So
Chris, what was the split in your time in terms of how long it took to implement async destroy and how long to create feature flags so that you could enable async destroy?
you mean how long to take Basil's code and make it work with async destroy?
Sure.
That took longer than to write async destroy.
How bad was async destroy?
Not that bad. It was.
Who do I blame for not having it earlier? it's like me fixing your bug, Keith.
Yeah. I think I stole a lot of things from like my first couple months where I was doing something totally unrelated that happened to have a lot of the same code. So it's maybe not fair comparison, but
it's a huge feature. Thank you so much. It's going to be terrific.
You had hinted at dependencies between feature flags?
Oh, I didn't really go into I mean, that's all, at the moment there's almost no visibility into it. So it's just kind of like you specify them programmatically in the kernel.
But keep in mind, we only have one feature so far, and it has no dependencies. So again, this is another area where when we have features that have dependencies, we're going to invent those mechanisms.
Okay, it seems like the ref count could be used to manage that.
They definitely don't want to do that. I thought about that.
But you don't have a mechanism already where features can say, I depend on another
there's
feature,
a
and so
mechanism when you
turn this
register
one
a
on,
feature.
The other one automatically gets turned
In
on.
the kernel, when ZFS initializes itself and you register your features, you can say, I depend on X, Y, and Z, and we did create some fake features to test that actually, like when you enable that, it enables all of its dependencies. So that's there, and then we want the disabling half where you disable and also check the stuff. But
Is async destroy going to be the first feature that uses the feature flags?
yes,
Sweet.
it is right now.